We work from actually kind of elementary up through middle school and high school, but the focus with our work on the math challenges has really been around the elementary and middle school. So I'm pleased to be with you today. Okay. You'll have to excuse me. I apologize. I'm still on the learning curve for WebEx, so until I get the hack of the sense of the technology, things may proceed a little slowly. But we have people at ETS that are here to help, so that's good to know. So I thought I would kind of like to start at what you might take as the beginning to share at least my picture of the math challenges and at least within the context of the algebra project, why we think they're important. So we've seen that the math challenges can kind of provide evidence for three things which we think are very important, right? Namely, students' understanding of mathematical concepts, also their ability to apply problem-solving strategies, and one of the issues that we consider very important, their ability to communicate mathematically. Right? And when I would like to actually go through one sample challenge with you, and this issue of communicating mathematically, I think, is important. We'll come back to that. But as you know, the purposes, I think, of the challenge, of the math challenges, there are actually two. They obviously provide the teacher, right, with evidence of how well students understand material, the mathematics that they're studying. But ideally, the challenge should also be able to provide students with similar information around how well they understand a concept. And that, as we go through this piece, both the information that students get and the information that teachers get, I think it's something that we should look at and talk about. There's an interest, I think this slide is particularly interesting. This is the theory of action, right, behind the math challenges. And as you see, it's looking at both teacher outcomes and student outcomes. Is it large enough for you to actually make out under teacher outcomes what's being targeted?
We're able to zoom in. There's an option to zoom in.
Zoom in?
Yeah, I can do it from my screen.
Okay.
Yeah.
Thank you. Cool. So, if you look under teacher outcome, content knowledge for teaching increases, teachers gather better quality evidence of student understanding, teachers facilitate and differentiate learning based on student needs. I think someone has just joined us, actually, Jafrana. Hello? Well, it doesn't look like she's connected in terms of voice, but when she is, we'll pull her in. So this is the theory of action. I'm wondering for the folks that are here, right, if you can share where you are with respect to these teacher outcomes, given what you've been doing with the math practices. Excuse me, math challenges. I'm jumping ahead in my mind. So, Awilda, Jose?
Yes. So What we have been working on is on problem solving, and what I found, as I told you before, sometimes the language is a barrier for them. For example, let me see. Okay, the rest. Last 2 weeks we have been working with problems where the unknown was in different positions. Sometimes the add-ins or the sum, or the subtrahend with subtracting, and just because they found one word that they don't know in the problem, they don't know what to do. For example, 6 marbles, 4 are red, the rest are blue. How many are blue? Just because they don't know that specific word, they don't get it. They just add everything together.
I see. So that's on the student side, right? In terms of student outcomes.
Yes.
But I guess I'm also interested in the teacher side of that equation. What we've blown up there refers to teacher outcomes, and we have those. Content knowledge for teaching increases. Teachers gather better quality evidence of student understanding, and teachers can facilitate and differentiate learning based on student needs.
Sure. So,
could you respond to those outcomes? You know, how do you? Because this is the theory of action, right?
Yes. So when I realized that they were lacking on that content, what I did was that instead of having just the problems in words, I tried to differentiate, and for some students, I try to model for them with pictures, right? I used to, for example, draw counters, and either, for example, make them red with an R, or just by drawing color, and then the rest, then I model what was the rest for them. And for some others that did not speak English, I just translated to them what the rest was in a definition.
Let's see, we've got a couple of other folks who have joined us.
I'm sorry for being delayed. This is Michael Nettles.
Oh, hi, Michael.
Hi. Yeah, I've been trying to get in on the web meeting and unsuccessfully, and so that's what took me a while. So I had to change locations and so that I could have a phone.
Okay. Well, welcome.
Thank you.
And Jafrana Castillo.
Yes, that's me. Good morning. I was also having difficulty. I'm not even sure if you could see that I guess you can. So I'm on the phone, but I'm not sure if I am going to be able to view the PowerPoint.
Okay, so you haven't gotten the PowerPoint up on the web yet?
I'm not sure if it's frozen or if it's that. I see a slide that says theory of action.
That's exactly where we are.
Okay, so I'm good. I'm on the phone, but I'm watching on the computer.
Okay, that's good. So actually, Jose and Awilda just took a moment to tell us basically where they're teaching, the grade level, and their experience with the math challenges. If you could share a little bit along those lines.
All right, so I'm teaching a bilingual 4th grade. And my students are basically students who come, I'm at PS73 in the Bronx, and they have either 2 years or less than 2 years in the country. I've done math challenges with them. They find it very difficult, and we have to do it in maybe 3 days, one challenge, and I have to translate it for them.
Oh, okay.
The language that they're not accustomed to that.
Right. Right. So, if you see, we have this theory of action behind the math challenges, and I was particularly interested in the teacher outcomes, right? Student outcomes, but first my interest is around the teacher outcomes. And there are three that are targeted there in terms of content knowledge, gaining evidence of student understanding, and really the ability to differentiate learning in the classroom. And I was wondering how that theory was related to your experience of using the challenges.
I have students in my class who can hardly read. I have some who are very at grade level, and I have some who are like intermediate. My coach teacher and I, what we do is we do grouping. So we do small group instruction. So let's say we're using a challenge on multiplication or using the area model. So we translate it to Spanish. We sit with a group with the regular challenge just translated. We sit because we teach our math instructions is in Spanish. And then she sits with maybe the intermediate, and then we both rotate back to the very low level, and we change either the numbers or the steps on we change the numbers or the steps, or sometimes we even have to change the operation. So we have to tweak it around in order to adjust it for the level of understanding.
Okay. So, if I can advance and to the next slide. So have you all seen this protocol for planning, implementing, and analyzing the math challenges?
Read patiently.
Yeah. Step one, review math challenge, meeting protocol, review and solve the math challenge prior to the PLC meeting. So from Gianfranco's description, it sounds like under the planning, you're engaging those all or some of those steps 1, 2, and 3. Am I interpreting that what you told us accurately, Gianfranco? I think I have pretty good wait time. So let me check in with either Jose or Awilda. This process for planning, delivering, and analyzing the math challenge? Have you all used some or all of this process on the occasions when you did implement a math challenge?
Yes. Usually when we have it, I'm with two cooperating teachers because our class is humongous. We have like, in one point, we have 31 students, but some of them passed the math exam and they were passed in other classes. So there were so many kids, and what we do is that after we gave them the math challenge, we review them, and we try to come up with ways of maybe making it better for the next time, and we discuss the responses, and we write down a set of questions that we ask the students to see how do they approach the problem, how do they see it.
Right.
As far as myself, I do review and solve whatever math problem that is given to the students, and I try to think and you know, put myself in their shoes and try to solve the problem as many ways as with different strategies as I can, so that when I approach the student, I have an idea of how is their thinking and what strategies they're using to solve the problem.
Okay. So does that occur as part of a team that you're on?
Actually, I'm all by myself in the classroom. I don't know how the other teachers are implementing it. I just know how I'm implementing it in my class. But it's just something that it is discussed during grade meetings, so I assume that they do it also.
Okay. Because, you know, at least in that previous slide, this theory of action, right? What strikes me as one of the things that strikes me as very important here is this issue of content knowledge for teaching. And at least when we've worked with teachers around these types of challenges, what we've seen is it is absolutely invaluable to have those discussions in these PLCs, right, with two or more teachers. That I think one of the things which we've really found is that working through the challenge with other teachers at grade level really changes the type of teacher talk, right, that occurs. So a piece of that, the teacher talk, is typically around what we call content knowledge, right, which is the math. And having other teachers to discuss this, you can really dig down into what's the big idea, right, behind the mathematics. The piece that complements that content knowledge is, you know, the fancy term for it is pedagogical content knowledge. And that's the issue of how students understand these big ideas. And again, we find that the discussions, the explanations, and the analysis of how students understand or don't understand, right, these big ideas is really aided by having, you know, at least a small group of teachers that are talking through this process, both, you know, at the planning stage and then at the analysis stage. So I think, you know, for a couple of you at least, you do have 2 or 3 other folks that you could engage in talking through the math challenge. I just think it's terribly important that this process doesn't kind of happen in isolation. If you can possibly find another grade level teacher to kind of talk through this, interesting things can emerge. That's what.
I do agree. Last year we did have, we participated in discussion and analysis of math challenges, and I found that it was very helpful not only for us, the staff, the educator, but also for the student. Unfortunately, in school that I am now, they don't practice it as much as I would like to. I do reach out to some of the teacher, to my mentor, actually. I do reach out to her, but as far as the other teachers, it's not happening, unfortunately.
Right. So, yeah, I don't know. Any way we can make that happen is, I think, well worth the effort. So, there's this, general protocol, right, for using the math challenge. Going from the initial planning, I think in the planning it's really important, just as was commented, that you solve the math challenge and really solve it in as many different ways as you can, right? And have an opportunity to talk to colleagues about that. Step 4 goes down to the implementation, and then 5 is concerned with the analysis and the rubric that you're using. I thought that we could actually look at a sample math challenge that I have up here. And if I can get to it. Good. So this is I wasn't sure who we would have, so I picked this one. It looked interesting, at least to me. This is from the 5th grade. It's focused on place value. The Common Core standard is below. And we have about an hour, correct? Or less than an hour. So my thinking was to look at the problems, but because we really don't have the time to work through the problems during the session, I wanted to kind of push ahead to the answer key. So that we could together kind of, look through the problems, look at the answer, and discuss just the content for a little bit. So just a moment. So if you see the question there, each large square below has been divided into 100 smaller squares of equal size. Each large square represents 1 unit. And then A is asking them to shade in a portion of the large square. And similarly in B. Good?
Yes.
See if I can Whoops. I haven't managed full control of it yet. So we're then asking which number is larger, right? And how do we know? We're asking students to shade in the squares on these two blocks that represent the sum, and to actually state what the sum is. So actually, that's problem one. So let's if we could talk about problem one a bit. What's the big idea behind problem one? What are we really trying to get the students to think about here? What are your thoughts on this?
I would say decimals, percentage, if they're able to identify, you know, what percentage of 100 it's being, they have to shade in. So basically percentage and out of a whole.
Mm-hmm. Other thoughts?
I'm thinking about how much is shaded from the whole, and what the decimal point 48 is on this in the square.
Mm-hmm. So what proportion of the square? What did you say the point 48 is?
Mm-hmm.
Okay, right, yeah. I'm tracking. Thank you, Jose. Other comments on this? What's the big idea behind this? Identifying a percentage, you know, a portion of the whole. Actually, as Jose just said, attaching that, accurately representing, say, 0.48 as a part of the whole. Any other thoughts on the first problem here and what?
Well, students, it'd be the ability to add decimals and understand fractions, convert those decimals into fraction, and also identify which number is bigger, less than, equal to, or greater than. So I figured that some of the students do have difficulty adding those decimals, and also identifying that that the period is 70 and not 7%. So also identifying the amount of quantity when the number is represented in either fraction or decimal.
Mm-hmm. Mm-hmm.
I think
good.
I think
Okay. Yes.
Yes, I think that this exercise is also to know if your student has the concept of the value of 0 right here.
Okay. Right. Right. Could you elaborate on that a bit? If the 0 comes in.
Yes. Let's see. You see, on the 70, well, let's start with the decimal first. 0.48 and 0.7. The students need to know the knowledge of the 7 is a 70, not just a 7. If it would be 7%, it will be 0.07 on the 70. Then, because if I see it as a 48, because it has 2 digits, I'm trying to think like a student right now. I'm gonna think that the 48 just because it has 2 digits is a larger number. It's a greater number.
Right. Yeah, that's a common misconception that, you know, is actually persistent all the way up into high school.
Sure.
I mean, you know, that is a real issue at almost every grade level. So, from what you mentioned, there's a piece that I'd like to take off on this, and it's with our students, how do we read these numbers, those 2 numbers that are there?
Student is 0.48 and 0.7.
Greetings. It's good to see you. Okay, so how would students read those numbers?
0.48 and 0.7.
Okay, so I would also suggest that there's a big idea here behind this problem that is suggested in this write-up, but which I think through teacher discussion can be made much more explicit. And so the way I'll describe this big idea is with a couple of points, right? And it's one that this has actually been mentioned implicitly in the discussion that we've had. But the first point is that a number has many names, right?
Okay.
And that, you know, in a sense, the name that we choose for a number depends upon what we would like to count with. So when I look at the numbers in this problem, just as you said, the 0.48 and the 0.7, if I was going to use the more accurate name for those, then for the first number, and this is difficult in English because, you know, I'm not very good with THs, so I'm going to put a lot of emphasis on this. But the first number is 48 hundredths, right? And the second number is 7/10. So just like the whole numbers, you know, 23, 47, 428, a place value reading of that first number would be 48 hundredths, and the hundredths would tell me what I'm counting with, right? So if you look at the write-up, they say if you count with the little squares, then you're counting with hundredths, right? If you count with the column or rows, then you're counting with tenths. And the importance of this idea that a number has many names, actually, Jose, I think you mentioned it because at one point when you mentioned how you compare them, for the 7/10, there's also another name, right, for that same number, which is 70 hundredths. And, you know, it's easy for kids to decide whether 48 hundredths or 70 hundredths are larger or smaller. So, just in addition to what you said and the considerations that came out, I think that there's this other big idea which has to do with how we actually read the numbers. This notion that numbers have many names, and that we can choose the name that we want to call it. And then, so in the place value system, you know, it's, do we name the number by tenths, by hundredths, by thousandths? And these PHs always get me. So I typically have to put a lot of emphasis on. But is this piece making sense to folks? I'm wondering how, you know, how you all respond to that issue around many names, the numbers.
I like the idea of renaming, especially because let's say if I had to show, instead of showing, or maybe if a student that doesn't like decimals, well, it's actually the opposite. I usually, when I was a student, I always went to the decimal because I was more familiar with it.
You like decimals over fractions, you think?
When I was a student, yes, yeah. I always converted. But I've learned some ways now that I'm like in fractions. If renaming for it for this kind of number, it's very important because if instead of showing in decimals, we put 48 over 100 or 70 over 100, it's different. You know, it's different. They might get it visually easier than this, but if they don't know that the 7 is a 70, they will only shade 7 squared of the whole square.
Right. I agree with you.
Yes. So, Awilda,
no, I was just saying that I agree with you saying that student would see that as a 7 instead of a 70. So viewing it as a fraction, they're able to identify that it's actually 70 over 100 rather than 7 over 100.
Mm-hmm. Mm-hmm. And you also notice by actually using the place value name, whether it's 7/10 or 70 hundredths, the place value name tells you what you're counting, tells the student what's being counted. Right? Am I counting tenths, which are the rows or the columns, or am I counting hundredths, which are the tiny squares there? Because all of this doesn't make sense if the child doesn't know what the counting is referring to. Right?
I want to go back to the value of the 0 again, because
say that again. The value
of 0. If 0 is the value.
Yes.
I think it's very important that we emphasize on this because I do extended date with 3rd graders, and they're actually doing something like this, where you give them the number, like say 507, and they're asked. There's a small chart where they have to jot down how many hundreds, how many tens, and how many ones, and mostly let me see. Most of the time, they confuse the ones on the tens because there is on the tens. If the number is 507, they always put that 7 on the tens, not on the ones. I don't know how if you guys understand me what I know.
I fully understand what you're saying. I believe that the problem comes in when they have the thought that 0 is nothing. So when they
correct.
That 0 in the 10th place, that 0 is nothing. So why is it not 57 and instead of, why is it 507 instead of 57? Because 0 is nothing, right? So if they see it as, I'm eating 0 cookies, then how come that zero is there. They don't understand that a zero could also be a place value, and even though it's nothing to them, quote unquote, we need that zero. We would come by, like, for instance, if we put that zero before the 1, it is a 1. But we put it after the 1, then it's a 10. So I think that's what the confusion, some students have confusion in.
Yeah, and, you know, the concept of zero is actually not an easy concept. It took humanity centuries to even develop a symbol for it, right? The Roman numerals, there was no symbol for zero because it was nothing.
Yes.
So, just the history of the number zero indicates that it's going to be tricky for kids if it took adult mathematicians centuries to finally nail the concept in. Okay? But what I moved ahead of page because this issue of kind of zero and being close to it comes up in this in question 2. Right, where they're looking at the numbers which are either closest to zero or closest to 1. Well, the first part is looking at closest to zero. Can everybody?
Yes, yes.
See the question and the response?
The closest to zero is 0.033.
Okay, so here's my request, right, for this session, and it's going to feel kind of odd, but I think it would be good if we practice the place value names, right?
Oh, okay.
So how would you want to read that for the place, in terms of its place value name? Because the place value name, in a sense, it tells you what you're counting, right? Am I counting by tenths, hundreds, or thousands?
Oh, I know what you mean now, because the first 3 here, it's on the ones. But how do you name the next 3, the one after it? Okay,
so the number, I'm going to use point language, 1.16. What are the different place value names for 1.16? Anyway, not just Jose, you know, Jalfrada, well, jump in here.
Well, isn't it after just 1 and that isn't that point, like they call it, turns into an and? So isn't it read 1 and 16? I don't know. Do I have? I don't. I'm
16 shares, let's say. Let's
right.
We help each other. You know, we're all in this together.
One whole and 16 share more shares.
And 16 cents, right? Or 1,600.
Right. So would be 1 and 1600s.
So here's my question. Here's another name. If I was going to name that number by saying I had 116 of something.
Yes.
It's 106. It's 116 of what?
Of 2 wholes.
1.16. You know, the trick is what I'm sure you guys do this with your kids around decimals. You say, think of money. I got 116 what? Right?
Yes. Okay.
Well, referring to money, then we have, it's like Jose was mentioning, then we have 116th out of 200, which is $1.16 out of $2. No.
Yeah, or I actually guess even not going that far, you got 116 pennies.
Exactly.
Right? Each penny is 100.
Okay.
So I have 11600. Yeah, Jose, go ahead.
But I have another, will be maybe a comment. I don't like to use money because...
there are reasons, but go ahead.
Yeah. Because let's say, for example, have a $1 coin, one dime, one nickel, and one penny. The nickel looks bigger than the dime, and then I won't. If I were to be like a third grader, I wouldn't see the connected Y system bigger than the other one. You know, so I don't know.
I understand what you're saying because here in the real world, we do have coins for, instead of a dollar bill. But if you notice in the classroom when we have the manipulative, we don't have those dollar bills those dollar coins. We only have dollar bills. And I guess that's the reason why, so we don't confuse the students, because it's like you're saying, I will see at the coin, and the coin is larger, so I assume that it's, it has a greater quantity amount, but I guess that's the reason why we have bills for dollar bills instead of coins in the manipulative that we use in class. I don't know.
Okay, that's what I mentioned before. Maybe I would show it with I have out of the 2 holes, I have 1 hole and 16 more shares. But since we're talking about the decimal, now it will be like a little obstacle for me. Yeah, for me to teach this.
Well, but I think what we're trying to do in this conversation is to target or at least what I'm trying to do is to target a particular difficulty that arises if students name numbers, but within that name, they don't know what they're counting. And the strength of the place value system is that if it's cumbersome in the beginning, but if you can get students to actually name their numbers, right, that they're reading off by place value, the place value tells them what unit they're counting with, right? So this 1.16 doesn't tell you what unit you're counting with, right? 1 and 1600 tells you what you're counting with. 11600 tells you what you're counting with, right? 2.2 tenths tells you I'm counting with tenths, and I have 2 of them, and then I have less than a whole tenth, but I have 2 parts out of that 100. So I guess, the point that I just want to push on this, and what we're doing here, right, in terms of dissecting the problem, is what I would hope, teachers would be doing around their initial discussion of the problem, right? So the question that we started with was, so what's really the big idea which drives this particular problem? And at least from my perspective, it's one of number names which explicitly tell me what I'm counting. And the kind of standard 1.16 doesn't explicitly tell me what I'm counting. Right? 1 in 1600 tells me I'm counting in hundreds. Or 9 tenths tells me that I'm counting in tenths. And with the pictures, right, that are there, what's nice about it is, if I'm counting in tenths, you can see the columns right there. I can see just what I'm counting. If I'm counting in hundredths, I can see the little square, just what I'm counting. And if I take the time, I could actually count them all, right? So this, I mean, I hope when you have these discussions that certainly the folks that are here, that with, you know, with the teachers you're working with, I think you always have to raise the question, so what's the big idea behind this piece of mathematics? Because if you can make that big idea explicit for yourself, you can make that big idea explicit for your children. And it's that big idea which helps the children make sense out of the mathematics that they're doing. Am I making sense to you all?
Yeah, yes, I think. Correct me if I'm wrong. Out of the big idea, what you mean is telling them why are we doing this, right? For example, if I have 160, let's say if we compare 160 with the block, I can show you that it is the same thing as 16 tenths.
Mm-hmm.
Right? Good. Okay.
Right. Right. And I think Shafrana, I think we lost her. But Awilda?
Yes.
I mean, does this connect with the issues that you're working with in your classroom in any way?
Yes, it does. Yes, it does. Actually, it does. Some of my students, at the beginning of the school year, we were working with place value, and even some right now that you don't get the concept, they cannot read the number, you know, using their place value chart. So it's something that, yes, definitely I could relate and I could see, you know, compare it to what's happening in my classroom.
Okay, that's good. I mean, we want to be relevant. I don't want to go too far afield. Actually, what I would like to do is to jump back to the PowerPoint because the issues we've been talking about are things that we've in the algebra project been attending to for quite a while, since the founder of the algebra project, Bob Moses, began working on these issues in mathematics education. I thought I clicked on it, but I had started working on these issues in mathematics education in the mid-'80s, and this same issue around language, right, and its meaning is something that we're still dealing with. Very quickly, there were a couple of additional points before we get to the algebra project. Right, this connection with the mathematical practices, and for the math challenges, I think one of the strengths of the math challenges is that they provide an arena, right, where students can work and focus on these mathematical practices. So, for example, the issue we were just talking about, number one, with numbers and their names, I would tag, first of all, to the math practice number one, make sense of problems and persevere in solving them. And, I mean, the first act of perseverance is in making sense of the problem, right? So the utility of using different place value names for the same number is that it helps students make sense of place value and number and the problem, right? Because the message that it's giving them is, you got to know what you're counting in order to name the number. Am I counting little squares? Am I counting columns or rows? Am I counting things in units of the big square? So these mathematical practices, and I think this is one of the strongest pieces that has come out of Common Core, because these practices go across K-12. I mean, if students internalize these practices from kindergarten up through 12th grade, this nation will be where it wants to be. And the point that I'd like to emphasize is, you know, here's a small little world, right? These math challenges where you can really focus in on maybe one or two of these practices, right? And scaffold, right, the investigation so that children really begin to internalize this practice.